There is a reason Jupiter has 67 confirmed moons. It is the solar system's vacuum cleaner. Its gravity is so immense, so commanding, that it captures passing debris, turning wandering asteroids into permanent satellites. It is a chaotic, violent process that has happened naturally for 4 billion years. But we are about to get moon number 68. And for the first time in the history of astronomy, the mathematics suggests that this capture is not an accident. The object is designated 3I Atlas. 3I stands for the third interstellar object ever detected, following Oumuamua in 2017 and Borisov in 2019. But unlike its predecessors, Atlas isn't just passing through. It isn't visiting. Astronomers have been tracking it since early 2024, treating it as a standard comet, a frozen chunk of ice and rock tumbling from the void. But as the data accumulated, as the weeks turned into months, the orbital models began to break. They began to show a destination that was too specific to be random. 3I. Atlas is executing a precision approach vector toward a gravitational region known as the Hill radius. This is not a term used lightly. In orbital mechanics, the Hill radius is the sweet spot. It is the precise boundary where a planet's gravity dominates the sun's pull. It is the only zone where a spacecraft can park itself in a stable orbit with minimal fuel consumption. New calculations reveal that 3I, Atlas, is targeting this zone with an accuracy that makes scientists deeply uncomfortable. We are not talking about a close flyby. We are not talking about a collision course. We are talking about an insertion maneuver. But the most terrifying part of this story isn't about Jupiter. It's about us. Because on its way to the gas giant, 3I, Atlas flew past Earth. It passed within sensor range, and it did absolutely nothing. It didn't slow down. It didn't scan. It didn't hail us. It ignored human civilization as if we were nothing more than background radiation. What you are about to see is the evidence that we are not the main characters in this galaxy. We are simply the indigenous population watching a ship sail past our island toward a more strategic port. This is the story of 3I, Atlas. To understand why astronomers are panicking, we have to talk about the dartboard problem. Space is big. It is incomprehensibly empty. When a natural object, a rogue comet or asteroid, enters our solar system from interstellar space, it is essentially falling blind. It is influenced by the gravity of the sun, pulled into a hyperbolic curve, and then flung back out into the void. The chances of a random rock entering our system and accidentally aiming for a specific gravitational stability zone around a specific planet are astronomical. Jupiter's Hill radius extends roughly 53 million kilometers from the planet's center. It is a massive region, yes, but in the scale of the galaxy, it is a pinhead. Now, look at the numbers for 3I, Atlas. The calculated intercept point for this object is 53.445 million kilometers. The margin of error, plus or minus 0.06 million. This isn't just close. In the world of ballistics, this is a bullseye. If you threw a dart from New York City aiming for a dartboard in Los Angeles and you hit the exact center of the red dot, that is luck. But if the dartboard was moving at 29,000 miles per hour and you were spinning and you hit that red dot, that is not luck. That is guidance. Skeptics, and there are many, argue that this is just a statistical anomaly. They say that with enough rocks floating in space, eventually one will look like it's aimed at us. It's the law of large numbers. And for months, that was the official NASA stance. It's a coincidence, until the object disappeared behind the sundae. In any covert operation, the most critical element is the timeline. You don't make your move when everyone is watching. You wait for the lights to go out. In astronomy, the lights go out during solar conjunction. This is the period when an object passes directly behind the Sun from Earth's perspective. The solar glare blinds our optical telescopes. The massive electromagnetic interference from the Sun drowns out radar and radio signals. We become effectively blind. For 3I, Atlas, this blind spot lasted between 40 and 60 hours, a blink of an eye in cosmic time. But long enough for a maneuver. Before the conjunction, the object was on a trajectory that would have taken it near Jupiter, but likely not into a stable capture orbit. It was coming in slightly too fast, slightly too wide. Then, it went dark. When 3I, Atlas, emerged from the glare, the parameters had changed. It had accelerated. This is what scientists call a non-gravitational acceleration event. Gravity didn't do this. Something else pushed it. Now, the standard scientific explanation for this is outgassing. Comets are dirty snowballs. As they get close to the Sun, the ice heats up and sublimates into gas. This gas shoots out in jets, acting like natural rocket thrusters. This pushes the comet. It's a well-documented phenomenon, but there is a catch. Natural outgassing is messy. It's chaotic. Jets erupt randomly from different sides of the rotating rock, causing the comet to tumble, wobble, and spin wildly. The trajectory change is usually unpredictable. 3I, Atlas, didn't tumble. Spectroscopic analysis of the coma, the cloud around the object, showed it was unusually symmetrical. There were no visible jets, no wild rotation. The acceleration it experienced was smooth, constant, and applied in the exact vector needed to refine its course toward Jupiter's hill radius. If you were a pilot, and you needed to correct your course without looking suspicious, you would do exactly this. You would wait until the glare of the Sun hid your ship from the primitive observers on Earth. You would fire your engines gently, masking the exhaust as outgassing. You would use the laws of physics as your camouflage. The timing is simply too convenient. The correction was too precise. For 100 years, humanity has been obsessed with first contact. We write books about war. We make movies about peace. We imagine grey aliens landing on the White House lawn, or monolithic ships hovering over Johannesburg. In every single one of these scenarios, there is a common denominator: us. We assume that we are the destination. We assume that any intelligent species crossing the Gulf of Stars would be interested in us. We are the narcissists of the galaxy. 3I, Atlas, shatters that narcissism. On its way to Jupiter, it passed relatively close to Earth. Close enough that even a basic sensor suite could have picked up our biosignatures. Our oxygen-rich atmosphere. The chlorofluorocarbons in our air, a definitive sign of industry. The cacophony of our radio and television leaks. We are the loudest thing in this sector of the galaxy. We are screaming, "We are here!" And yet, 3I, Atlas did not react. There were no course corrections to get a better look, no orientation shifts to point sensors at our cities, no thermal spikes indicating data storage activation. It drove past us like a commuter driving past a patch of dry grass on the highway. This indifference is known as the roadside effect. If you are building a highway through a forest, you do not stop to communicate with the ants near the construction site. You do not hate the ants. You do not love the ants. The ants are simply irrelevant to your mission. If 3I, Atlas, is indeed an artificial probe, its lack of interest in Earth sends a chilling message. We are not a threat. We are not a partner. We are not even a curiosity. We are barely a footnote. So, if not us, then what? Why fly light years just to orbit a gas giant? This brings us to the Sentinel Theory. This theory posits that advanced civilizations do not explore the universe in person. Biology is weak. It dies. It needs food, air, and sleep. Instead, they explore by proxy. They send von Neumann probes, self-replicating, autonomous machines designed to monitor star systems for millennia. If you want to set up a long-term listening post in a solar system, Jupiter is the only logical choice. It is the ultimate strategic high ground. Reason 1. Energy. Jupiter has the strongest magnetic field in the solar system. It is a dynamo. A sufficiently advanced probe could harvest this electromagnetic energy to power itself indefinitely. No solar panels required. No nuclear batteries to replace. Just free, limitless power from the planet itself. Reason 2. Camouflage. Jupiter is noisy. It emits massive amounts of radio waves and radiation. To our primitive Earth-based telescopes, looking for a small probe next to Jupiter is like looking for a firefly next to a spotlight. The radiation belts provide a natural cloak. They blind our senses. If you want to hide a base of operations, you hide it in the glare. Reason 3. Stability. The Hill radius contains the Lagrange points gravity pockets, where an object can stay fixed relative to the Sun and Jupiter forever. From a parking spot in Jupiter's L1 point, a Sentinel probe would have a continuous, unobstructed view of the inner solar system. It could watch Earth. It could watch Mars. It could track our asteroid belt. It sits there, drinking energy from Jupiter, shielded by radiation, watching the monkeys on Earth learn how to build fire, then steam engines, then atom bombs. The leading hypothesis among the Sentinel proponents is that 3I, Atlas, is a carrier craft. It is not here to observe us directly. It is here to deploy the network. Once it hits that Hill radius stability zone, it may release a swarm of smaller, microprobes. These probes will scatter, taking up positions across the Jovian system, and once they are deployed, they will be too small to see. The network will be live, and we will never know they are there. Why are we seeing this now? Is it a coincidence that the moment humanity invents artificial intelligence capable of processing massive astronomical data, we suddenly find an anomaly? Perhaps 3I, Atlas, isn't the first. Perhaps it's just the first one we caught. For decades, astronomy was done by human eyes and simple scripts. We looked for things we understood. Comets, asteroids, planets. But in the last 5 years, we have handed the telescopes over to AI. The Vera Rubin Observatory, the James Webb Space Telescope. They are feeding petabytes of data into neural networks trained to find outliers. And the AI is finding things that shouldn't exist. It is finding fast movers, objects moving too fast to be rocks, but too slow to be light. It is finding transients, objects that appear for a single frame and then vanish. It is finding micro-lensing events that suggest invisible, heavy objects drifting through our system. Scientists call these glitches. They call them sensor errors. But there is a growing whisper in the data science community. The glitches are real. We are like a man who has lived his whole life in a dark room. Suddenly, someone hands him a flashlight. He turns it on and realizes they have been standing there, in the dark, the whole time. 3I, Atlas, might just be the latest delivery truck for a construction project that has been going on for millions of years. As you watch this video, 3I, Atlas, is entering the final phase of its journey. NASA will continue to call it a comet. They have to. To say otherwise requires extraordinary evidence that we simply do not possess yet. But the trajectory remains. The mathematics remains. The indifference remains. We used to look at the stars and wonder if we were alone. Now, we have to ask a different question. A scarier question. If the Sentinel Theory is true, what are they waiting for? Are they protecting us? Are they quarantining us? Or are they simply waiting for us to make a mistake? Jupiter has 67 moons. Welcome to number 68. It's not a rock, and it's watching you.